To our last talk before the break by Professor Yeong from Purdue University, and the talk's entitled Theoretical Analysis and Reaction Mechanisms for Experimental Results for Hydrogen-Nickel Systems. Professor Kim.
This is
And also, apology to Dr. Castle, we found your talk was intended for this period, so we'll talk with you during the break.
My voice is very weak, so I want to have a voice amplified enough so that you can hear me. Well, I have only 20 minutes, and my theory has been published in reference 2 through 15. That's an abstract. So I won't go into detail of how the theory developed. Only use the conclusion to present things. So let me start with the first slide. As you saw in the demo, that same R5, the current hyperon reactor, and some of the internal structure is shown. In particular, you notice two spots coming. And this dimension is maybe 9 inches or so. Okay, and what they did was change cubic crystal, base center cubic crystal, to C4 or PM3M structure of this type, and fabricated powder, and the powder looks like this. Size is about 5 microns. And these are inserted into those pore, which is on average about 200 micron. So this is about 5 micron. This cell is 200 micron. So that's the idea what's involved. Okay, now the trigger reaction, but they preheat the system to 180 degrees, and then trigger. Trigger involves about 24 kilovolt direct current. Magnitude is about 22 milliamp, and has several K frequency. So that's the triggering mechanism. And what's surprising is that when you trigger, you do see a very huge magnetic field created, 0.6 terasol. This is about 20 centimeters from the center of the reactor. And after triggering, it increases to almost 3 times, 1.6 terasol. Huge magnetic field is created by the whatever nuclear reaction or whatever reaction is happening. Triggering only gives a 0.6, while the reaction taking place increases that to 1.6 terasol. So the magnetic field is very involved in the process. And you can think of this way: if you have two pole, which is the case, you do create this kind of electric field pointing from positive to negative. And if you ask what is the current, the magnetic field created by a particular current, take one loop, you can calculate using this familiar formula. And so these collectively, many of them are producing excess magnetic field. So definitely magnetic field is playing very important key role to do the reaction. Other thing, I'm going to go through what they found. There is no hard nuclear gamma rays above ceramic cavity. And some of the data they gave to me, when exit happens, this gamma ray shows up. This is with the sodium iodide, and you can see. I think they are planning to use much more accurate gamma ray detector, such as high purity German crystal. It's coming. And another striking thing they found was that only even nuclear nickel powder produces heat, while the only one of the isotope is 61 does not produce a heat. This is a really interesting result which John told me at NI week last August. And so this is something theory has to explain. One data I observed when I was visiting May 15 and 16 is shown here. And they degassed before they did that, and then introduced the hydrogen. And then degassed. This is 1 day time difference. So they did a degas sufficient time in order to get carbon data like that. As you can see, you can terminate at will by cutting off this triggering current. And then you can restart anytime you turn on again. So the control seems to be there. So let me now try to explain what's going on theoretically, based upon my theory, not anyone else's. So, as I said before, all of the detail of my theory can be found in this published papers, conference, presentation, and so on. So I just summarized what our theory is doing. The theory is developed to explain Flash-Pond effect. That's the main purpose until this hydrogen nickel thing came along. And so we did develop a theory. Theory involves main body Schrödinger equation, solving the bound state problem. And we found when you have a many boson occupying ground state, which is allowed because of spin, then some cases it can be Bose-Einstein condensation. In general, it's boson cluster state in the ground state. And if you have such a state with many bosons, that we are thinking of about 10 to 10 bosons or deuterons in 10 nanometer radii. Then that's one unit. The fusion, we have shown that the Coulomb barrier can be overcome if you have enough number of deuterium in boson cluster state. So when you prepare many of them, there is a reaction rate to pop up those named deuterium. And in order to conserve the total momentum, we proposed that it has to explode symmetrically, including all the deuterium and helium created in there. Now this is, I call type 1, having one nucleus produced in the final state. This is a freshman point effect. And the reason why the other channel doesn't have a high probability is that once you try to go to this exit channel, this has to go through the additional photon barrier penetration to go out, as well as if you look at the energies involved, centrifugal barrier as well. So they have to penetrate those two barriers to get to this state, and that costs drop probability compared to this case. You don't have that problem. So if you take the probability 1 here, probability for those channels could be much, much less. So that's the explanation based upon our theory for freshman point effect. And as far as I'm concerned, it's solved. I can argue with any of the nuclear theorists who object this. I can discuss them and convince them this is correct theory. Okay, so now we have to extend this to hydrogen metal phase. If we generate this already, reference 3 is actually published in ICCF-18 France. So it's 2006, I think. So we made a generalization. If you have 2 different species of the boson, how does the formula develop? And the formula looks like this. IJ would be 2 different species. This case, hydrogen has to form pairwise boson to be able to participate in this formula. The reason this is useful is that every experimenter who does experiment and wanted to compare experiment or reaction rate, you have this very compact formula which you can use to compute your case and then see how well it compares. This is almost parameter-free theory. Only thing we don't know about is a different channel aspect that is related to nuclear force strength. And the other thing is the probability of whether your experiment is creating enough probability for occupying boson cluster state. Now, boson cluster state need not be both Einstein condensation, but it could be. But in general, you don't have to be. If you have a cluster of boson, that is sufficient to use this formula. So this is a very useful formula, and as the Fukarians start creating data, like using a new online real-time mass spectrometer, first thing we will do is compare with this formula, see how they compare, and more importantly, how relatively different reactions comes out of this formula compared to experiment. And of course, if the agreement is not there, we have to think whether this is reasonable or not, or in turn, we have to think whether we made an incorrect thing. So this case, generalized mechanism will be, again, type 1 channel will be just having one nucleus. Now, the reason I want to emphasize this is that if you have this situation, you have to impose a total momentum conservation so that it will induce so-called nano explosion. So if you just extend everything from previous case, you get previous fractional point case, you get this kind of classification. Again, this is as a matter of probability because this area has to go through. So the probability of this channel is much smaller than that. So this is quite general formula. It can be any nucleus you're talking about here. And yet the formula I wrote down earlier can be applied. Now, I realized after I started looking into a lossy case as well as the flying case, start thinking, why is the NICO so important? Doing their job for them. I think by knowing magnetic field being generated by triggering and that start the reaction implies that magnetic alignment of nickel atom on the localized surface of nickel powder must be happening. Remember, even before reaction starts, when you trigger with current, you create 0.6 Tesla magnetic field, so that even though temperature is above the Curie temperature, nickel can align along the magnetic field and create a local magnetic field. So that's the importance of nickel's role in all of this process. And once that happens, you can imagine that those spotwise magnetic field created on the surface of nickel can act as a trap for the photons if hydrogen can be excited and then having electric moment created for them and then start pairing them, become boson, and so that they will participate in the reaction. So that's what it is stated. Okay, and this is a very important slide. We have a hydrogen molecule, a nickel powder like that, and you do the plasma growth discharge to create a 0.6 Tesla magnetic field, and so this growth discharge will create excited hydrogen atom, which is called Rydberg state. And nickel is magnetized above Curie temperature, as I discussed before, and create many of the localized magnetic trap, many on the surface. Those trap will trap the many clusters, and once that happens, then my theoretical description can take over. And once that happens, many nanoex, you can imagine many of the, depending upon reaction rate, you will create many nano explosion. And that's almost like having grow discharge. Effectively, you are creating localized raw discharge, but if you look at the entire thing, it's just very effectively same as the children case. So you can foresee that if you increase reaction rate enough, you can self-sustain reaction. Instead of going this route and ending up somewhere, you can go back and start this loop. So this loop will be a self-sustaining reaction. So the question is that possible? And so let's look at what's happening. Now, there's no hard nuclear gamma rays. And that's almost impossible if you are talking about this kind of one particle final state. Even though this is stable, many others are not. And furthermore, even though this may be stable, it could go to excited state of the stable nucleus. In this case, create a hard gamma. So all of these reactions involved, except this two, will create hard gamma rays. And so that's inconsistent with the experimental observation. So we would say that this type of reaction may not be a primary reaction, but much weaker secondary reaction. And you may observe this as isotope ratios and so on, but it cannot be major process of creating sufficient heat. So what else can you think of? Of course, this has to be tested experimentally. So this is my first conclusion. Not the first conclusion. I'm skipping something else here. Even isotope effect was predicted in our paper in 2006. If you can form the hydrogen pair boson cluster and behave like a boson, then it cannot coexist with fermion neutral isotope happens to be half into this spinning fermion, so that our prediction here can be applied to this case as well. So NICO 61 will not be able to participate in the boson cluster nuclear fusion to overcome Coulomb barrier. Now, if NICO proton transmutation is not the main process, what would be? We don't know yet, so there is a need for the experiment to find that out. But you notice that in hydrogen gas or water, whatever, you can't avoid the deuterium impurity. It's already there with it, this much. And the question is, can that participate in this kind of process in the reaction chamber? And indeed, you can if you have it's about 10 to the 4 hydrogen with one deuterium. Then you got the one boson sitting in, let's say, sitting in the center, and then surrounded by the paired hydrogen, maybe half smudge. So you can have a two boson system doing the boson cluster fusion. And of course, knowing this Q-line, you can guess what would be a reaction. Now, if this is indeed a process, then there is a hope for making this self-sustaining. Remember, if this is a process happening now with a very small admixture of the deuterium. You can imagine adding more deuterium to it and then bring up the reaction rate sufficiently large so that it will self-sustain. So this experiment has been done, and the Korean group is trying to do this, see whether this prediction is correct or not. First of all, you have to take the heating Hopefully online real-time mass spectrometer. The Korean asked some company to develop. They built the two of them. It looked like that, almost finalized. And this is the segmented octapole ion light. And there are two of them being built. One will go to Vancouver lab, the other one go to Athens. Always they want to cross-check two identical experiments with identical setup. So that's coming. I don't have time.
Oh, sorry. Sorry to put off such interesting work.
Okay. Do I have 1 minute?
People who would like to go to the break is set up, otherwise remain.
Oh, okay. Yes. Now, please leave now if you don't But let me spend the 5 minutes to go through the rest of the slide. I had only 20, instead of 43, a people had. But he messed up the trick. Okay, so let's go back. Future plan. Just read through. One thing is that the parent is definitely trying to put the 1% of the revenue. Now 1% looks very small, but let's say you are creating $10 billion revenue out of this type of thing. That's $100 million for basic research. So as a professor at the university, I am very happy that there are finally will be funding coming. You can just read through. And theoretical approach. So far, we have been, I'm old style physicist. I don't like to use a computer or cell phone and so on. I'm old guy. I'm 80 years old next month. So I don't use computer the computation. So everything, all the derivation I did was paper and the pencil type derivation so far. But that's not enough. That gave some good stuff. So it's called the time independent linear. And I'm just solving a main body Schrödinger equation. But you really need a time-dependent, non-linear equation solve. So that's collaboration with the National Instrument Group being done now. I'm happy that they like to collaborate. And actually, Dr. T, the keynote speaker, pushed this collaboration, and we are doing that. This is my final slide. It looks like high volume reactor gives result with very reliable control and high reproducibility. Personally, I think this is a breakthrough. I agonized 24 years when the experiments is going to come through, give me the breakthrough result. Waiting, never happened. This may be one. I am convinced one, but of course other people may not. Yeah. Now, the fact that they are very basic science-oriented group, trying to do this mass spectrometer. Build. Actually, this cost $2 million for 2 kids. So they are curious about science. And theoretical understanding with the simplified theory we have appears to give us some qualitative description and understanding so far. So this field is revolutionary clean technology, emerging as this technology. And I think we are creating now very new field, multidisciplinary thing. Now, we were already dreaming this will happen. But until we have a breakthrough, we couldn't. We suffered. Okay, so this is my logo. Cold fusion is becoming hot.
Thank you very much, Professor Kim. Let me just quickly ask, does anyone feel stepped on or have something to refute? Because otherwise, more detailed discussions, I'd like to keep it private because we're so slammed. Yes.
I apologize in advance, Dr. Kim, for asking you this, but I have just 3 quick.
You say you're harassing me?
Apologize. Now, Callion implied that they had tested nickel pure isotopes. Do you have any evidence, any notebook entries, any invoices, anything?
Not to me. Unfortunately, let me tell you.
Second question.
Yeah, yes, Yeong was supposed to be here, but they had the air traffic controller strike at Milan, so he couldn't show up here. And I'm prepared to answer all of the questions.
I know, but some of these questions are on many people's minds. The radiation detection, I designed a lot of that equipment. Did they collect any data outside of the equipment that I had designed?
I don't know.
The third question was the heat that they claimed, 8+ kilowatts, why wasn't the room a steam bath? That's a lot of heat in a small room.
8 kilowatt.
Steam is a heck of a lot of heat. You have a room about the size of
I think they were venting it to the, they were putting it directly down the drain. That's what said there.
Well, thank you very much. I'm sorry that I have to call the session just for